All right. I'd like to welcome you this afternoon to our UNL Beef and Forage focused webinars. These are webinars that are held twice a month on the first and third Tuesday of the month. And today I'm pleased to have Denny Bauer with us. He's an extension educator located in Brown, Paha, and Rock counties up in kind of the northeast central part of the state. And he's going to address custom mineral mixes and are they feasible, kind of talk about some cost-effective ways to use those with beef cattle, especially in range type situations. Before Denny gets started, if you have questions today as we go through the presentation, you have the opportunity to type those in the chat box, and then I will be fielding those and helping Denny to answer those or passing those off to him as he goes through his presentation. With that, Denny, I'll let you get started.
Okay, good afternoon. It's a pleasure to be on the program today. And I guess, the question we're going to try to answer today is, can you custom mix a mineral, and are they feasible? And I think before we start, looking at mineral programs, need to get a little bit of a handle on where we're at as far as producers are on the cost of minerals. And if you look, for example, at $850 a ton mineral, and you're feeding 3 ounces per head per day year-round, you're going to have about $29 in each cow in mineral supplementation. And we do have some mineral programs that are out there that are over $1,200 a ton. And if you're feeding 3 ounces of that product today, you're over $42 a head in mineral supplementation. And is it possible to be up here at $250 or $450 a ton on mineral, still meet mineral nutritional needs of the cows, and not hurt reproductive performance or any other parameters that you want to measure, and be in this $8 to $15 a head per year range on mineral supplementation? That is the question that we're going to try to answer today. Before we get into the forage testing and some of the research trials, I think just a brief review of the NRC requirements for mineral nutrition on beef cows. Phosphorus is set at 0.12 to 0.21%, depending on the cow's stage in her reproductive cycle. 0.12 would be on a dry cow, and 0.21 would be during lactation, for example. The copper requirements, according to the National Research Council, has been set at 10 parts per million for copper on beef cows, and it can range from 4 to 15. And there are some antagonistic elements that will cause some antagonism with sulfur, high molybdenum, and high iron, and that's why it can range some. But basically, 10 parts per million in most of the diets will suffice for the copper requirement. Zinc requirements on cows has been set at 30 parts per million with a range of 17 to 30, but basically we use 30 parts per million. Zinc will cover the cow's requirements. Now the other requirements listed in the NRC are potassium at 0.6, magnesium 0.1, manganese at 40 parts per million, and selenium at 0.1, sulfur at 0.15%, and so on. You can see those are the other ones. And we'll discuss those here just a little later in the presentation, but not in a great detail, and I think you'll see why as we get into some more of the data. Would visit just briefly about a few of the research trials that have gone on in the past few years on trace mineral supplementation, and then try to get into why we don't see a lot of response, and in a lot of cases no response to supplemental mineral supplementation programs. In this study done by the University of Nebraska, this was reproduction on 2-year-old cows on trace mineral supplementation. Notice that the control was dical and salt. The organic treatment was dical and salt with copper and zinc added, and then inorganic forms of copper and zinc was the other treatment. This data was pooled over 2 years. You can see that 2-year-old cows, about 80 in each group over 2 years. Number of opens, there was no statistical difference. Calf gain, no difference, and weaning weight was not different amongst the treatments. So in this particular study, over a 2-year period, copper and zinc really had no influence on the reproductive performance of those 2-year-old cows. In the Journal of Animal Science in 2004, the study by a gentleman out of Colorado State University, they looked at different treatments, looked at copper, zinc, and manganese supplementation and source on reproduction and mineral status of grazing beef cattle over a 2-year period. And they numerically did have a little higher preg rate with the organic and inorganic supplementation, but the calf performance actually was just the opposite, where the control, where they didn't supplement, those calves were actually heavier at weaning than the 2 supplemented treatments. And so again, that's a little hard to explain, but that's what the data shows. Pretty inconclusive that mineral supplementation there did a lot of good for those cows. In 2004, out of the UNL beef report, phosphorus requirements for finishing heifers, looks like the break point for average daily gain suggests that the 0.115% phosphorus of the diet dry matter is more than adequate for yearling heifers on feed. In 2000, at the UNL beef report, in 2000, copper levels and source of pre and post calving diets for first calf cows, calf health and cow pregnancy rates were not affected by addition of copper to the diets fed pre and post calving. And a couple other data sets here in UNL beef report in 1999 really had no effect of copper, cobalt, manganese, and was supplemented at high levels. Do not affect a lot of the parameters they measure for pre-brutal heifers that were supplemented. Really no difference there. And again, in the beef report in 1998, phosphorus requirements for yearling steers, the data would suggest that 0.14% of the diet dry matter or less would be adequate for yearling steers. And Dr. Erickson in this report basically said if you were supplementing any corn-based diets in the feedlot, probably did not need to feed any supplemental phosphorus. That just gives you a brief summary of some of the data. There's just tons of research trials out there, and the majority of them are inconclusive. There may be some numerical advantages to some of the mineral supplementation, but statistically it's just pretty hard to find concrete evidence that supplemental mineral programs have increased the productivity or any reproductive type performance on cows. But why would that be? And I think this is probably the meat of the program today, is to talk about why that might happen. So we're going to spend just a few minutes talking about some analysis of forages, and I think by the time we get done going through these next several slides, you will have a good idea of why we don't get a response to a lot of the mineral packages that we feed. This first data set is analysis of western Kansas and Nebraska, roughage samples. We looked at cane hay. They looked at cane hay in western Kansas, grass hay in western Kansas, and then Nebraska sandhills hay. If you look at the phosphorus content, these are just averages at 0.17, 0.12, 0.11. You notice the phosphorus levels there would meet a dry cow's requirements in just about all cases. The copper is at 8. And the cane hay in Kansas a little bit lower in the sandhills and in western Kansas. And the zinc, again, is not quite up to the requirements at 30, and copper being at 10 parts per million. Manganese, for the most part, was met. Another data set, this is dryland spring planted cereal annual forages grown, and this was data from the University of Wyoming at Cheyenne and the High Plains Ag Lab at Sydney. You look at barley, oats, triticale, peas, soybeans, and vetch. Look at the phosphorus there, all way above even for lactating cows. We meet the phosphorus requirements. Potassium is at 0.6 is the requirement. We're 3-4 times higher than they are for what the requirements are for potassium. Magnesium is adequate. Sulfur is adequate. Manganese is adequate. But we're borderline on copper and about half the requirement for zinc. I should mention copper was at 7 parts per million in the old NRC. In the latest edition of NRC, they actually moved it up to 10 parts per million based on a couple breeds of cattle that excrete more copper, don't utilize it quite efficiently. And so, when we talk about 6, 7, 8 parts per million, for most cows, that would be adequate, and that's why we don't see a major response to the addition of copper in those cattle's diets. Another data set, these are the summer annual forages, again from the Nebraska High Plains Ag Lab at Sydney and in the Panhandle Research and Extension Center at Scotts Bluff. And this is dryland. The phosphorus level is, again, close to meeting, dry cows' requirements. Potassium's met. Bottom line, in copper is close to being met, but we're short on zinc. And this is the irrigated trials basically on those same grasses, again, from Sydney and Scotts Bluff. Probably a little more fertility, a little better growing conditions under irrigated situation. Phosphorus levels at 0.2 or better. Again, copper is close to meeting requirements, and even the zinc levels are just almost adequate, just a tad short. Another data set from Colorado, Kansas-Nebraska, and you can take a look at that. You look at the copper levels in the mid-range, slightly deficient probably, and the zinc levels are low. Most cases, all those different types of forages, whether it be from Colorado, Nebraska, or Wyoming, doesn't seem to make a lot of difference. Phosphorus levels are adequate in most cases and on most of the forages that are being fed. Here's a data set from the Sand Hills, and this is basically in Brown, or Rock, Cherry, and Holt counties, the study that was done, and you notice the copper levels, zinc levels are pretty close to meeting requirements. I wouldn't be too scared about that if we had the diet that contained 25 or so parts per million zinc. The phosphorus levels are pretty high, and so on. I throw this one up. This is out of the Northern Great Plains. This is from Dr. Cody Wright at SDSU. Even just to point this one out, annual brome grass, which we'd consider a weed. Look at the nutrient content on phosphorus at 0.3, 2.7% potassium, zinc levels at almost the requirements, and pretty high levels of copper and high levels of manganese. So even some of our annual weeds have pretty high levels of mineral concentration in them. Here's some data from Nebraska Ranch Practicum. This is by Dr. Jerry Valesky at UNL, where they went on the meadows and they harvested on June 20th, right here, or on and then the regrowth on September 20th, or they harvested on July 12th, and then the regrowth on September 20th. And on those different cutting dates, you can see for example, here on the phosphorus, when they harvested on June 20th, it was 0.15. The regrowth was at 0.22. In this case, the phosphorus level didn't drop, by 3 weeks later in the cutting season to 0.15, and the regrowth was at 0.23. And over here on the right, I've listed the requirements according to the NRC. And, all of these four these samples basically meet the requirements except for zinc and copper. And in this particular, manganese was also just a tad short on this data set. But a lot of the times manganese would be met. This leads us into a study that we did in 01 through 03, where we sampled about 1,000 samples in 11 counties in central northeast Nebraska. I want to give credit to the educators that were involved in this particular project. Troy Walls, Custer County, Brent Fluge, who's now down in Buffalo County, Ralph Kalm, who was in Holt County, who's now retired, and then Bud Stolzenberg, who is retired out of Cherry County. But we had producers that brought samples to us, or we went out and sampled for them. We sent all the samples to Ward Laboratories in Kearney, an independent lab, and had them run mineral analysis for us. What I'm going to report on right now are about 800 of those samples. And if you'll notice here, we had 223 alfalfa hay samples over that time frame. Could be either irrigated or dryland. It's whatever the producer, told us. Up here, you'll see these are the requirements according to NRC. And here are the different minerals, and most importantly, when you see the percentages in these boxes, that is the percent of the samples that tested at or above the requirement for that particular element. And so alfalfa we know is a great source of calcium, but 100% of those 223 samples tested high enough to meet calcium, potassium, magnesium. 99% of them were high enough to meet manganese requirements, and 98% of them met sulfur requirements for the cow. We had 320 meadow hay samples, and again in the 90 percentile on all those different elements out of just our straight meadow hay. If we were just feeding straight meadow hay, for example, oat hay, high 80s to 100. Millet, which could have been either pearl millet or foxtail millet, irrigated or dry land, 90 to 100% of the time, all those elements were being met on the diet based on the content. And then alfalfa grass mixed, again in the 90s. So a lot of the other mineral concentrations are high enough in these forages to meet the cow's requirements. But let's take a look at the phosphorus, zinc, and copper. Probably the bottom line here today. Alfalfa, right at 100% of the samples met phosphorus requirements, but only 15% of the alfalfa hay samples were at 30 parts per million or better for zinc, and only 5% that were over 10 parts per million for copper. Meadow hay, about a third of the samples tested high enough to meet phosphorus requirements, and we're just borderline on phosphorus in a lot of our samples that'll run 0.1, 0.12, 0.13, just right at the borderline. But again, short of zinc and short of copper. Oat hay, millet, and alfalfa grass all in the 90 percentiles on meeting phosphorus requirements, but none on copper. I do think it's interesting that millet, actually half of the millet samples tested over 30 parts per million. The millets must have an affinity for zinc and able to pull zinc out of the soil a lot better than some of the other plants, for example. But again, copper and zinc was probably short. This was data I just picked up. This is from the Forage Analysis from cow-calf herds in 18 states. This cow-calf health and productivity audit conducted by Dr. Larry Cora from Kansas State University. And wanted just to look at cobalt and selenium. This would be out of the Midwestern states. If you remember, the requirements are 0.1 for cobalt and 0.1 for selenium. And I got this listed in parts per billion, but if you just move the decimal point over 3 places, it'd be like 0.39 parts per million. And alfalfa, Sudan grasses, the cereals would be like oats, rye, barley, wheat. Native would be our native warm season grasses, and the grass component here would be like brome grass, bluegrass, and those kind of grasses. But basically, cobalt and selenium were being met for the most part in all these samples in the Midwestern states. The reason we didn't test for cobalt and selenium in a lot of our sampling was that each one of those tests are at that time where it's about $25 a pop for each sample, and so testing for those two elements are pretty expensive. Just to summarize some of the data, I think from the last 20 years is pretty conclusive. Phosphorus levels in most forages are adequate for the dry cow, and in a lot of cases for the lactating cow, especially when we talk about supplementating with some of the distiller's grains and other products. Copper concentrations, not high enough to meet beef cows' requirements for the most part. And on average, 50 to 65% of the cow's requirements for zinc is supplied by the forage. So we're just, according to the results, we're just a little short on zinc and copper. Mineral requirements for calcium, potassium, sulfur, iron, and manganese are met 90 to 100% of the time based on the forages that are being tested, along with cobalt and selenium. Even though the data, again, on cobalt and selenium is a little bit thin because the testing is pretty expensive for those. But from the data I've been able to look up, in most cases, we are probably okay on that. I would recommend producers actually test for selenium and cobalt if they're really concerned about it or if they have a production problem. Moving on, let's talk just a little bit about the corn byproducts or co-products for the beef cow and what that can do in rations, and why we may not look at any supplemental phosphorus in a lot of our mineral programs. Phosphorus being the most expensive part of most mineral programs. The byproducts are excellent source of protein and energy, and more importantly, and for this talk, really high in phosphorus. Just a simple diet here. You got a forage base at 6% protein and 50% TDN, 1,200-pound dry cow. Here's her requirements on protein, TDN, and how much phosphorus that cow would require. Our base forage, she eats 23 pounds of that on a dry matter basis. That's what we get out of the forage. And if we feed a couple pounds of DDG on a dry matter basis, you notice that we've met protein, energy, and more importantly, we're over on the phosphorus content. And so anytime we start feeding a couple, 2-3 pounds of DDG to any class of beef cattle, probably have met the phosphorus requirements, which leads us into then a no-phos mineral program, or can. Here's probably the worst case scenario from a mineral standpoint. You see the distiller's grain up here at 0.83% phosphorus. If we're on corn stalks or feeding corn stalk bales at 0.1% phosphorus, and our grass hay average 0.13 on all those meadow hay samples. But if we take a look at the corn stalk ration, here's the forage first, our meadow hay at 0.13 and 2 pounds of DDG. We are just from 19 grams requirement to 18.3 being fed, we are just so close to meeting the phosphorus requirements that I guess we wouldn't worry about that. If you look at the corn stock example, 1,250-pound cow, 200 days pregnant, and she consumes 23.8 pounds of corn stalks either by grazing or being fed, and 2 pounds of DDG. Again, here's her requirements. You notice that we are just short. I mean, not enough to worry about on phosphorus, but we are short, about half on the copper, and we're short on some zinc. So if we were going to do a custom mineral mix, for example, on this, with this type of feeding scenario, what might that look like? And again, this is probably the worst case scenario. Corn stalks are the lowest testing thing that we can find as far as phosphorus, but we might think about putting the mineral in a pellet or cube. If we're going to feed them 2 pounds of DDG cake a day, why not just add the copper and zinc into the cube? And now we're feeding 2 pounds a day. Every cow will get some of that. What you would need to do would be to put about 2/3 of a pound of copper sulfate per ton of that cube, and about 1/3 of a pound of zinc oxide per ton to meet that cow's requirements for copper and zinc. That would cost you about $1.70 a ton to add that to that cake. And that's been very effective. We have several producers that are doing that, and then they just free choice salt on the side. Another way is to actually mix up a mineral mix that contains no phosphorus, 1,500 parts per million copper, and 2,000 parts per million zinc. And this is what that would look like. 12 pounds of copper sulfate, 6 pounds of zinc oxide, and 1,982 pounds of salt. Last fall, we were getting that mixed up, bagged and mixed for about $160 a ton. Okay, and if you feed 2 ounces of that product a day, that'll meet the cow's requirements for copper and zinc, and that is less than a penny a day per head. Talk just a little bit about forage management. Fertilizing can increase the phosphorus content. The forages would never recommend doing that alone. The growth stage of the plants do affect the mineral content. Usually as the plants weather and they get more mature, the mineral content can go down. Here's probably the most important one that we ought to take a look at is what about the availability of minerals from the forages? People would say, well, we only know that a certain percent of those, like phosphorus, for example, is available to the cow. A portion of it is not going to be utilized by the cow. But the neat thing is all the research that has been done has already taken that into account. When they run diets, the researchers run diets, they analyze the forage, and the availability then of those elements have been taken into account when they do their feeding trials. And so we know that not 100% of the phosphorus in any forage is available to the cow, but again, that's already been taken into account on all the recommendations in the research trials that have been done. And so what test you get back from your labs, you can use them to formulate diets with. Here's a chart just sort of summarizing 1,200-pound dry cow. Her requirements are 0.12 to 0.16 phosphorus, depending her stage of pregnancy. And then in lactation, it can run from 0.16 to 0.21 phosphorus. On the left side, I've put the base forage. And let's just take a look here. Say here's our meadow hay at 0.13 on all those samples that we tested. If we would feed 2 pounds of DDG, her diet would contain 0.19% phosphorus. If we fed 4 pounds of DDG, we would be at 0.25% phosphorus. Now, if you're not feeding distiller's grain, for example, and I went to, here are the same forages at 18 pounds, but we're feeding 6 pounds of alfalfa hay for our protein supplementation part of the program, with that same amount of that meadow hay, then we're at 0.18% on phosphorus, which would meet the cow's requirements, sure, as a dry cow, and part of her requirement for phosphorus during lactation. And I think it's important to remember that cows, store minerals, and they can draw some of their body reserves, so they can be short on some of the minerals in their diet for fairly long periods of time, actually, and not hurt reproductive performance. And I think, when we talk about DDG, for example, there's a lot of other supplements that contain high levels of phosphorus, and we should always take that into account. For example, soybean meal is 0.7% phosphorus, almost as good as DDG's. Sunflower meal contains 1% phosphorus, actually higher than DDG. Wheat midds are also at 1% phosphorus. Cottonseed meal is at 0.6% phosphorus. And so no matter what kind of supplement we're feeding, if we're starting to feed, 2 to 3 pounds of any of those supplements, we really need to take account of the phosphorus in those supplements and then balance accordingly, which can really help save quite a few dollars in mineral supplementation. I think what we need to remind producers is to test your feeds, and then based on those tests, we can maybe have a custom mix made. I would also suggest that you take bids on mineral. If you're going to do a custom mix, go to your local feed supplier and say, I'm going to take bids today, here's what I want mixed up. Eliminate overconsumption. Cows don't need to eat mineral every day. In fact, there's data out there that would suggest that dry minerals, only about 85% of the cows ever eat mineral. And so not every cow is going to eat mineral, and some sure don't eat it every day, and they don't need to eat it every day. So if you're going to take out a pound per head per week, for example, if they eat it in 5 days, they can go a couple days without mineral. So don't let them overconsume. And this one here, feed mineral, the amounts and kinds only when needed. Usually green grass this time of year, we probably would meet just about all the would meet the mineral requirements, especially phosphorus, on this lush green pasture. That's something you might want to think about too. We do have producers that are just feeding mineral late summer, late August, September through April, and in May, June, July, and August, basically just put out trace mineralized salt and get by just fine. In summary, I think it is possible to custom mix a mineral to meet your cow's herd's requirements. I think the mineral cost on a per cow basis can be, as low as $5 per head per year. And if you're spending over $15 to $20 per head per year on mineral, you might want to get a second opinion. Bottom line, test your feed supply for mineral content, including your protein and energy-based supplements. And with that, there's a nice sunset. And for more information, you guys, anybody can give me a call. I've listed my office number right here, my 800 toll-free office number, and then my cell phone is there. You can reach me 24/7. And also, if you want to email me, you can do that too. And with that, I want to thank you for your time today.
All right, thanks, Denny. Any questions for Denny you want to put in your chat box before we wrap up today? Denny, I appreciate your time, appreciate your thorough analysis of the data to demonstrate the recommendations for minerals for beef cows and how the opportunity may be there to take advantage of doing some cost-effective supplementation and planning around that. So appreciate your time today, Denny. Again, if you have any questions for Denny, His contact information is on the screen. You either reach him by email or by phone. Before we conclude today, I do want to remind you that on Tuesday, June 5th, we are going to have Aaron Stocker be on the program. Aaron's going to talk about storing and using wet distillers grains on the ranch. Frequently in the summertime, there are opportunities to purchase wet distillers grains from plants, as that seasonally is when fewer of those wet distiller grains are being used by feedlots. And so there is an opportunity to purchase those in the summer and then store those for use as a protein supplement during the winter. And Aaron's going to be on, talk about some methods to use to store that, and then also how it can be delivered to cattle on the ranch. Appreciate again you joining us today. This presentation today will be archived at the beef.unl.edu website under Beef Webinars. For joining us.